Let us learn about the prerequisites of surface areas and volumes. The following are the concepts discussed as the prerequisites of surface areas and volumes. Geometry, plane geometry, solid geometry, volume, surface area, cylinder, cone, sphere, hemisphere, cuboid, cube. Geometry. Geometry is all about shapes and their properties. Geometry can be divided into two parts. One is plane geometry, and the other is solid geometry. Now, let us see about plane geometry and solid geometry. Plane geometry. Plane geometry is about flat shapes, like lines, circles, and triangles. For example, circle, rectangle, and triangle, etc. In mathematics, plane geometry was the traditional name for the geometry of two-dimensional figures. It is called two-dimensional, or 2D, because there are only two dimensions, that is length and width, or breadth. Solid geometry. Solid geometry is about three-dimensional objects, like cubes, cylinders, and prisms, etc. In mathematics, solid geometry was the traditional name for the geometry of three-dimensional figures. Solid geometry is called three-dimensional or 3D because there are three dimensions: width, depth, and height. Solids have properties. Some of them are volumes, surface areas. Volume. Volume is the amount of space that a three-dimensional object occupies, and it is measured in cubic units. The most commonly used units of volume are millimeters cube, centimeters cube, meters cube. Int. Volume means, think of how much water a container can hold. Surface area. In general, the surface area is the sum of areas of all the shapes that cover the surface of the object. The most commonly used units of surface area are millimeter square, centimeter square, meter square. Int. Surface area means, think about the area you would have to paint. Cylinder. It is a three-dimensional figure, having two parallel bases that are congruent circles. Note, two objects are congruent if they have the same dimensions, that is, length, breadth, height, and shape. From the figure represents a cylinder, where h is the height of the cylinder, and r is the radius of the base of the cylinder. Let us see some of the formulas related to cylinder. The curved surface area of a cylinder, CSA, is equal to 2 pi RH. Total surface area of a cylinder, TSA, is equal to 2 pi R into R plus H. Volume of a cylinder is equal to pi R square H. Note, total surface of a cylinder, TSA, is equal to area of the circular top, plus area of the circular base, plus curved surface area, CSA. This is equal to pi R square plus 2 pi RH. This is equal to 2 pi R square plus 2 pi RH. This is equal to 2 pi R into R plus H. Cone. It is a three-dimensional figure, with one vertex, and a circular base. Here, a right-angled triangle is imagined to be formed, so, by applying the Pythagoras theorem, the slant height is given by the formula. Slant height L is equal to square root of R square plus H square, where R is equal to the base radius, H is equal to height. Let us see formulae related to cone. Curved surface area of a cone, CSA, is equal to pi RL. Total surface area of a cone, TSA, is equal to pi R into L plus R. Volume of a cone is greater than or equal to 1 by 3 into pi R square H. Note, total surface area of a cone, TSA, is equal to curved surface area, C sigma, plus area of the circular base, is equal to pi R square plus pi RL. is equal to pi r into L plus r. Sphere. It is a three-dimensional figure, with all points in space at a fixed distance from a given point, called the center. Hemisphere. In geometry, it is an exact half of a sphere. Let us see some of the formulas related to sphere and hemisphere. Curved surface area of a sphere is equal to 4 pi r square. Curved surface area of hemisphere is equal to 2 pi r square. Total surface area of a hemisphere is equal to 3 pi r square. Volume of a sphere is equal to 4 by 3 into pi r cube. Volume of a hemisphere is equal to 2 by 3 into pi r cube. Cuboid. A cuboid is a box-shaped solid object. It has 6 flat sides, and all angles are right angles, and all of its faces are rectangles. Let us see the formulae related to cuboid. Curved surface area of a cuboid is equal to 2 into LB plus BH plus HL. Volume of a cuboid is equal to L into B into H, where L, B, and H are respectively the 3 edges of the cuboid. Cube. A cube is a box-shaped solid object that has 6 identical square faces. Let us see the formulae related to cube. Curved surface area of cube is equal to 6a square. Volume of a cube is equal to a cube, where a is the edge of the cube,